Hello, welcome again. We are solving some questions of fluid mechanics and machinery. The topic is viscous and turbulent flow. Question number 9 is the external and internal diameter of a collar bearing are 200 mm and 150 mm. Between the collar surface and the bearing, an oil film of thickness 0.25 mm and of viscosity 0.9 poise is maintained. The power lost in overcoming the viscous resistance of the oil when the shaft is running at 250 rpm is option A 22 watt, option B 26.48 watt, option C 23.28 watt, option D 22.12 watt. So this is your shaft and collar. Here suppose there is a film of oil, and let at a radius r the velocity is u. Then the velocity u is given by 2 pi r n by 60 or root omega by omega into r. Okay. Now from the Newtonian law we have tau is equal to mu tau is equal to mu du by dy. Here the velocity is at radius r, velocity is u, and thickness is t. Okay. So we can write it as tau is equal to mu u by t. Okay. So now consider a small strip of small element in the form of ring of thickness dr at at radius r, and then the force acting uh, on this ring is df, and that is given by tau into area of element ring. So shear stress is that we have calculated as mu into u by t, and the area of the ring element is your 2 pi r into dr. Okay. Now this is your small force. If you multiply by radius, then it will be a torque. Okay. Now your u is nothing but omega into r. So the overall expression for dt becomes mu into omega by t into 2 pi into r cube by r cube into dr. So t is your mu omega 2 pi by t r cube dr. So if we put the limits, we put these limits, because radius is varying from r1 to r2, then t is equal to mu omega 2 pi by t r2 4 minus r1 4 by 4. Okay. So mu is your 0.9 poise or 0.9 by 10 Newton second per meter square. R1 is 0.075 meters. R2 is 0.1 meter. Omega is your 2 pi n by 60 or 26.17 radian per second. And T is your 0.25 mm or 0.25 by 1000 meters. So putting these values, we can in this expression we can find out torque, that is 1.01163 Newton meter, and the power loss is just that is a torque. Torque is that is used to overcome friction. So power loss is T into omega, that is omega is 26.17, 26.48 watt. Is that right answer? So answer is 26.48. Next, a shaft of diameter 100 mm rotates at 60 rpm in a 200 mm long general bearing, taking that two surfaces are uniformly separated by a distance of 0.5 meters, and taking linear velocity distribution in the lubricating oil having dynamic viscosity of 4 centipoise. The power absorbed in the bearing is option A 3.961 into 10 minus 2 watt, option B 4.961 into minus 2 watt, option C 3.125 into minus 2 watt, and option D 4.11 into minus 2 watt. So so here the diameter of shaft is 100 mm, okay, and length of bearing is, here the diameter of the shaft is 100 mm and length of bearing is 200 mm. Okay. So T is your 0.5 mm or 0.5 into minus 3 meters, and mu is your 4 centipoise or your 0.04 poise or 0.04 by 10 Newton second per meter square. Okay. So N is your 60 rpm, and omega is your 6.28 meter per second. Put in the value of n. So linear speed of the shaft is omega into r. Omega is 6.28. R is your 1 by 2. That is 0.314 meter per second. And Newton's law is tau is equal to mu du by dy. So dy is your dy is thickness of film, 0.5 mm, and or it is 0.5 meter per minus 3, and changing velocity, that is velocity, it is 0.314 meter per second. So tau comes out as 2.512 Newton per meter square. And this is your shear stress. So shear force is tau into pi dl. So that is pi d is given, L is given. So the shear force is 0.1578 Newton. And the torque lost is F into R. So that is shear force, and R is radius. So the torque loss is that is in Newton, this is meter, 0.078113, and the power loss is again same way that we can multiply it by omega and find out power loss. So that is 4.961 minus 2 watt. Option B is the right answer.